Let's now find all angles theta such that the tangent of theta is equal to the negative square root of 3. To begin, let's draw the coordinate axes. And for this one, there are two possibilities. One possibility would be over here, so that the y-coordinate is plus square root of 3, but the x-coordinate is negative 1. The other possibility is down this way, where the y-coordinate is negative square root of 3, but the x-coordinate is 1. For either one, the y-coordinate divided by the x-coordinate would be negative square root of 3. And if I drew this right, this would be a single straight line for these 2 points. Okay, several ways this could be done. We could look at this angle over here as 2 pi over 3. And so I can write theta is equal to 2 pi over 3. And because the period of tangent is pi, I can write this as 2 pi over 3 plus pi times n. Unlike sine and cosine, there's no need to have two groups of angles to denote all the solutions. If I were to denote this as two groups of solutions, I would write this as theta is equal to 2 pi over 3 plus 2 pi n. That would be the one in the second quadrant. And down here, the angle here would be negative pi over 3 plus 2 pi n. And at first blush, it looks like the listing in orange is different than the listing in brown over here. You should convince yourself that these two sets of numbers are going to be the exact same thing as the set in brown. For example, if you plug in n equals 0, n equals 1, n equals 2, n equals negative 1, n equals negative 2 in these two lists, and then do the same thing in the first list that I wrote, you'll get the exact same angles. So it is better to write it more compactly in brown here as opposed to the two lists that I had originally.